Welcome everybody, this is the Chemistry Paper 1, Chemistry GCSE Paper 1, which was the paper that you did for your mock exam. You need to get yourself a green pen out and we're going to correct your answers. Question 1 was well answered. It starts off, in a hydrogen-oxygen fuel cell, hydrogen and oxygen react at the electrodes. The overall reaction occurring at the fuel cell is the reaction of hydrogen with oxygen. Write a balanced equation for this reaction. Well, it's got to be a balanced symbol equation, and most people are happy with that. And it's hydrogen plus oxygen goes to give water. Most of you are okay with that. You don't need state symbols, but you do need to balance it. Two hydrogens are okay, but I've got two oxygens, so I need two H2O, and that gives me 4 lots of hydrogen, so I need 2 H2. Now you've got 2 marks. You've got 1 mark for getting the formulas of the 3 compounds correct, and 1 mark for balancing it correctly to give you a total of 2 marks. Part B, it says the electrodes of the fuel cell are in contact with water and air. State why iron is not a suitable metal for the electrodes of cell, and that is iron corrodes or reacts with water and oxygen. You could also say that iron oxidizes as well, and that was acceptable. Platinum acts as a catalyst. State in terms of position in the periodic table why would you expect that, and most people got that. Platinum is a transition metal. And that's the answer. As long as you've got transition metal in there, you've got 1 mark. Part C says some metal objects can be electroplated. State 2 reasons for electroplating a metal object, and the 2 main reasons that they want is that it improves appearance, and you could say it makes it shiny. That was allowed as an answer. I don't think it's the best answer. The best answer, it improves resistance to corrosion. So improves resistance to corrosion. Or number 3, and you had to have 2 out of these 3, was that it makes cheaper metals look more expensive, which is different from improves appearance. So, and that's particular for jewellery. Makes cheaper metals look more expensive. Now, there is a 4th one that wasn't given in the mark scheme, which I did allow, and that's that it improves the conductivity, because you can use gold for plating electrode contacts. Question 2 again was well answered. It gives you a copy of the periodic table with some letters, and those letters are different elements, and it says use the letters to give 2 elements that are non-metals. Well, the step ladder between metals and non-metals goes something like that. You could have E, G or X. You're probably better if you're asked for 2 to 2 G and X, because E, it's a little bit unknown, but it is more of a non-metal than a metal. Give the letters of 2 elements in period 2. Some people made the mistake here. Period 1 contains hydrogen and helium. So period 2 contains lithium, whichever element that is, but it's A, E and G. A, E and G, and you had to have 2 of those for 1 mark. The 3rd one, give the letter of an element that normally forms an ion with a +1 charge. Well, that's going to be anything that's in group 1, so you can have A or J. And Part B, element E has an atomic number of 5. In a sample of E, there are two isotopes. One isotope has a mass number of 10, and the other isotope has a mass number of 11. Explains in terms of the subatomic particles what is meant by the term isotopes. Well, most of you got this. Isotopes have the same number of protons, but they have a different number of neutrons. That's the best answer. Isotopes have the same number of protons, but different, not more or less, just different number of neutrons. Part 2, all atoms of element E. Well, it says it's got an atomic number of 5, so it must have 5 protons. That was fine. Element X has an atomic number of 18. State the electronic configuration. Well, it's going to have 18 electrons, so it's going to be 2, 8, 8. Most of you were okay with that. In an experiment, 3.5 grams of element A react with 4 grams of element G to form a compound. Calculate the empirical formula of this compound, and it gives you the relative atomic masses of A is 7 and the relative atomic mass of G is 16. Well, the way I'm going to do this is I've got two elements. I've got A and I've got G. My empirical formula is the simplest whole number ratio of grams over rams. It's the simplest whole number ratio of moles of each element. So I write down the grams for A, which is 3.5, divided by the RAM of A, which is 7, and G is 4 over 16. And that gives me 3.5 over 7 is 0.5, 4 over 16 is 0.25. If I divide both sides by 0.25, or you can do it by just looking at it, that is 1 and this is 2. So it's 2 to 1. So then importantly, my formula is A2G. I've got 2 atoms of A to 1 atom of G. And if you did all that correctly, you got yourself 3 marks. Question number 3 was again quite well answered. Water acidified with sulfuric acid is decomposed by electrolysis. The water is decomposed to produce hydrogen and oxygen. A sample of hydrogen is mixed with air and ignited. States what happens. Well, that's the test for hydrogen gas. It burns with a squeaky pop. So burns with a squeaky pop. You could also say that water is produced, and you got 1 mark for that. The second part was the first time that we had a problem with our command words, and it says throughout the experiment the volume of hydrogen and the volume of oxygen are measured at 2-minute intervals, and then it gives some results in a table. And it says, describe, using the data in figure 2, what the results show about the volumes of hydrogen and oxygen produced in this experiment. Now, it very clearly says, describe the results in a table. It doesn't say explain the results. So you don't need to start talking about how the results are arrived, how you get the results. You just need to state what you see in front of you from the table. You need to interpret them. And as the time increases, then the volume of hydrogen increases and the volume of oxygen increases. But it increases at half the rate of the volume of hydrogen. And there were 2 marks. One for saying as the time increases, as the time increases, the volume of both gases increase, but the volume of hydrogen is twice that of oxygen. And those were the two things that you needed to say to get the 2 marks. Some people said that the volume of hydrogen was twice that of oxygen, and that's because the formula of water is H2O. Well, that would have been the answer if it had said explain these results, but it very definitely didn't. It said describe. And so it's a 2 mark describe thing. So you're looking for 2 things from the table that you can talk about. And it's very clear that those 2 things are that both gases increase linearly with time. If I double the time for both cases, if I go from 2 to 4, I go from 4 to 8 or 2 to 4. I double the time, I double the volume of both gases. But the hydrogen is produced twice as quickly as the oxygen. The multiple choice question says molten lead bromide is electrolyzed. The products of the electrolysis are, well, if you've got lead bromide, lead is less reactive than hydrogen, so you're going to get lead at the negative electrode rather than hydrogen. And bromine is a halogen, and you always get halogens if they're around. So you actually get lead and bromine formed, and you got 1 mark if you got that correct. The next part says calcium nitrate and calcium carbonate are both ionic compounds. Calcium nitrate, if mixed with water, behaves as an electrolyte, but calcium carbonate, if you mix with water, does not behave as an electrolyte. Explain in terms of the solubility and movement of ions this difference in behaviour. And it kind of gives you the fact that the solubility is the important thing. And of these 2, you know that all nitrates are soluble. So calcium nitrate is soluble. And the ions are free to move. If you said that, then you got the 2 marks, but you could also say that calcium carbonate is insoluble. The next part 1, molten zinc chloride is electrolyzed. Zinc 2 plus ions electrolyzed. Zinc ions form zinc atoms. Write a half equation for this reaction. Well, it's got to be zinc ions going to zinc atoms. So I can start off my zinc ions, and then I go to give zinc atoms. Now, all we've got to then do is decide where we're going to put the electrons. Well, a zinc ion has lost 2 electrons to become zinc has lost 2 electrons to become a zinc ion, and therefore it's got to gain 2 electrons, so it's got to be plus 2e minus here, and you've got 2 marks for that. If you've got zinc plus goes to give zinc, zinc 2 plus goes to give zinc, you got 1 mark, and if you've got the electrons in exactly the right place, then you got the 2nd mark. Question 4 again was quite well answered. It says calcium carbonate decomposes on heating. It undergoes a thermal decomposition reaction to form calcium oxide and carbon dioxide. If 8 grams of calcium carbonate was heated strongly for about 10 minutes, 6.213 grams of solid remained. That's your calcium oxide. Calculate the mass of carbon dioxide. Well, it's going to be 8.000 minus 6.213, which equals 1.787 grams. 1.787 grams for 1 mark. A second sample of calcium carbonate is strongly heated in a crucible until there is no further loss in mass. The mass of the calcium oxide remaining in the crucible was 5.450 grams. The theoretical yield of calcium oxide in this experiment is 5.6 grams. Calculate the percentage yield of calcium oxide. Well, the percentage yield is the actual mass over the expected mass. It's always going to be the smaller one over the larger one. They've called it the theoretical yield, that's the expected mass, and so it's going to be 5.450 divided by 5.600 times 100, so turn it into a percentage, and that gives you 97.3214 if you put all of those significant figures in. Now, there's nothing in the question that talks about the level of accuracy of your answer, and so it allowed any number of significant figures from 97.3 and any other, so 97, 97.3, 97.32 were all correct for 2 marks. And the last bit, the mass of solid left in the crucible was less than the theoretical mass of calcium oxide that should be contained. A possible reason for this is that. Well, the only answer that is going to decrease the mass is A, some solid was less from the crucible, B would increase the mass, D would increase the mass, and C would not affect the mass. So the answer has got to be A. Part C was the first part that started causing some problems, and it says another sample of calcium carbonate is heated and the mass of solid remaining is measured each time, and it shows you the time and the mass of solid remaining, and you can see from this the mass is decreasing as you would expect, but the decrease in mass is also decreasing. It's decreasing by a smaller amount each time. So as the calcium carbonate gets used up, the decrease in mass is less. Now it says explain the trend shown by the data in figure 2, and it's a 2 mark in figure 3, and it's a 2 mark question. Well, this time it's explain. So we're going to have to describe the results and explain them using the science that we understand. Now, there are 2 ways that you could get the 2 marks. The first way, and I think probably the easiest way, was to describe. The first mark was saying the mass of the calcium carbonate decreases because the calcium carbonate is losing carbon dioxide, and it's as simple as that. You could have got the 2 mark for saying that. So the mass decreases because, and that's the key word, isn't it? Because, explain, because, using science. The mass decreases because carbon dioxide is given off. Now that would have got you the 2 marks. You can also say that the rate at which it decreases is decreasing. So the second way that you could have got 2 marks is saying the rate decreases because the concentration of the reactants is decreasing, because the amount of of CaCO3 decreases, and this is particle theory. Therefore, there's going to be less collisions, and therefore there's going to be less rate of reaction. The rate decreases because the amount of carbon dioxide decreases, and actually that's all you needed to say. So you could either say for 2 marks that, or you could say that for 2 marks. Part 2 says it is impossible to be sure from this data that the reaction is complete. Well, when the reaction is complete, then you will have heated it to a constant mass, and The last figure, it's still losing mass. It loses mass all the time, but it loses less and less mass. But it's still losing mass, and therefore you don't know whether it's complete. I mean, you'd have to do another at 8 at 5.2 to know that the reaction was complete, and the next one might be 5.1. So the reaction is still losing mass. The reaction is still losing mass after 7 minutes, and that will get you that 1 mark. Part D was a very straightforward 2 marks. It's calculate the RFM of calcium carbonate. Ca1 times 40, C1 times 12, O3 times 16, and you do that and it equals 100, and you get 2 marks for that. Calculate the atom economy for the formation of calcium oxide in this reaction. Now, calcium oxide is the required product, so it's going to be the mass of calcium oxide over the total mass of products. It gives you the relative formula of 56, carbon dioxide is 46, which is going to be the same as calcium carbonate actually, which is 100. So it's going to be the relative formula mass of calcium oxide over 100, so it's going to be 56 over 100, which is the same as 56 over 56 plus 44, which gives you a value of 56%. Question number 5 says, one way to extract metals from land contaminated with metal compounds is phytoextraction. When plants grow, they absorb metal ions to their roots. The plants are harvested, dried and burned, forming an ash. The ash contains metal compounds. Plants were grown in a piece of ground contaminated with nickel compounds. 1 kilogram of the ash from these plants contained 142 grams of nickel compounds. Calculate the percentage by mass of nickel compounds in the ash. This really is very simple, isn't it? And this is 3 marks. You got 1 mark for recognising that 1 kilogram is 1,000 grams. And so the percentage is going to be 142 over 1,000 times 100, and it really was that simple, and that gives you a percentage of 14.2%, and the accuracy of your answer didn't matter, so you could have 14% or 14.2%. That was really a very easy, I think, 3 points there. Nickel is extracted from nickel compounds. State an advantage of extracting nickel by phytoextraction rather than from its ore. Many of you struggled with this actually, and it says ignore any references to cost, better for the environment, time or energy, which I think is where we went wrong, because many of you said those. The advantages of growing plants and extracting it is that you can extract metals from low-grade ores, so that would be one advantage. The other advantage is it says a specified environmental reason, e.g. less noise due to mining, less habitat destruction due to mining, it's carbon neutral and it produces less carbon dioxide. So any of those, but it had to be a specific environmental reason. So I'll put allows low grade ores to be extracted, causes less CO2, less habitat destruction, then mining. And any one of those would get you 1 mark. Some nickel ores contain nickel sulfide. In the first stage of extraction, nickel from nickel sulfide, in the first stage of extracting nickel from nickel sulfide, the nickel sulfide is heated in air to form nickel oxide and sulfur dioxide. Write a balanced equation for this reaction. Well, air is going to be, it says nickel sulfide, NiS, is heated in air to produce nickel oxide and sulfur dioxide, where you need to know the formula of sulfur dioxide, which is SO2. And obviously I've got nickel and sulfur on the left hand side, I've got nickel, sulfur and oxygen. So heating in air is going to be adding O2. Now you've got 1 mark of the 2 if you've got all of those formulas correct, and then you've got the second mark for balance it, which 2, 3, 2, 2, and if you got that, that was your 2 marks. Part 2 says in the final stage of the extraction process, a nickel compound is electrolyzed to produce pure nickel. An advantage of producing a metal by electrolysis is the metal is going to be very pure, is correct. It uses a large amount of electricity as a disadvantage. Electrolysis is very cheap. Well, it's not. Electrolysis is the only method of extracting unreactive metals, and it's not. So that is the best answer. In a different method of obtaining nickel, the process produces a mixture of liquids nickel tetracarbonyl and iron pentacarbonyl. The boiling point of nickel tetracarbonyl is 43 degrees C, so it's presumably a liquid at room temperature. The boiling point of iron pentacarbonyl is 103 degrees C, and it says these 2 liquids, and it says liquids mixed together completely. Now, describe the process used to separate these liquids. So all I'm doing is describing how I can separate 2 liquids with quite different boiling points, and the answer is distillation, which is used to separate liquids. And you could put fractional distillation, but actually distillation was allowed, and you got 1 mark for just writing the word distillation. And really the second 2 marks, from what I can see of the mark scheme, there was 1 mark for saying that you heat the mixture, and then you, after between 43 and 103, then you will be getting the nickel tetracarbonyl, which you need to condense. And so really the second 2 marks were saying that you heat the mixture and then you condense the first fraction between, which is below 103 degrees C, and then you condense the second fraction above 103 degrees C. So distillation, heat the mixture until the first compound boils at 43 degrees C, and collect this by condensing it, collect the second compound above 103 degrees C. And that would get you the 3 marks. Question number 6 was the first question that started causing some people some problems, and it says hydrated copper sulfate, CuSO4, with 5 waters attached to it, which is 0.5 H2O, is a blue solid, Anhydrous copper sulfate, which doesn't have water attached to it, is a white solid. Heat energy is needed to convert hydrated copper sulfate into anhydrous copper sulfate. This is a reversible reaction. Now, it is a reversible reaction. It doesn't actually have to reach equilibrium. And many of you, the first thing that you said was that you had to do the reaction in a sealed container. Well, it doesn't actually have to reach an equilibrium. It says devise an experiment to show that it is a reversible reaction. Well, the experiment really is quite simple. If you heat the blue copper sulfate up, it will lose water and turn into the white copper sulfate. That's the reaction in the forward direction. Now, to make the reaction go in the reverse direction, you have to add water back to the white copper sulfate to turn it back into blue copper sulfate. And if you said all of that, you got 4 marks. And if we just have a look at where the marks went, you got 1 mark for saying heat the blue copper sulfate. So, you know, you're going to have to put in some detail here. Heat it in a test tube with a Bunsen burner. So, heat the CuSO4.5H2O in a test tube with a Bunsen burner. And then the second mark was for saying that it turns white until it turns white and water is given off. And that gives me my CSO4 and water given off, steam is given off, whatever. Now, my white, and then I need to, the second step, add water. This is the step that many people didn't get, is add water to the white CuSO4, and it will turn back to blue CuSO4.5H2O. And that will get you all 4 marks. The first mark for heat, the second mark for it turns white or produces water, the third mark for add water to turn it back, and the fourth mark for saying that it turns blue, or that heat is released in the reverse direction. So the reaction takes in heat in the forward direction, so I could add heat here. It's a reversible reaction. It takes in heat in the forward direction and it actually gives out heat when you add water to your white copper sulfate. Now, the second part was quite an interesting one. It says hydrogen reacts with iodine to form hydrogen iodide. Iodine gas is purple and hydrogen iodide gas is colourless, and it gives you an equation. It's a reversible reaction. Hydrogen iodide is placed in a sealed container. The container is left until equilibrium is reached. So this time they've moved on from a reversible reaction to talking about equilibrium, and it's allowed to reach equilibrium. The conditions are changed, favouring the forward reaction. Explain what you would see. Okay, now you start off with hydrogen iodide, which is colourless, and that's all you've got in your tube. It's going to reach an equilibrium, and as it reaches an equilibrium it becomes more purple because more iodine is produced, because iodine is the only one out of those 3 things that is coloured. So when it's at equilibrium, it will be a certain intensity of purple. It says the conditions are changed to favour the forward reaction. Well, the forward reaction, the amount of iodine decreases. It doesn't disappear, it doesn't get rid of it. It won't, if it's an equilibrium in a sealed container, it won't get rid of all of the iodine. So it won't become colourless. What you will see is that the container will become less purple. And the reason it becomes less purple is because there's less iodine present. And so explain what you could see is explain why you see that colour change. So the container becomes less purple because less I2 is present. And there were lots of things where you said that it became colourless because lots of hydrogen iodide was produced, and that's not the case. What you see is you see the purple colour, you don't see the hydrogen iodide, and therefore you have to talk about the purple and what causes the purple colour, which is the iodine, the I2. Part C was quite straightforward, but some people made a real meal of this. It says calculate the number of atoms in 1 mole of copper iodide. Well, the Avogadro's constant, 6.02 times 10 to the 23, is the number of atoms in a mole. So if I had a mole of copper, it would contain 6.02 times 10 to the 23 atoms. Now, copper iodide is a compound containing 1 atom of iodine and 1 atom of copper and 3 atoms of iodine. So it contains 3 atoms. So a mole of copper iodide will contain 3 moles of atoms. So the answer is 3 times 6.02 times 10 to the 23, which is equal to 1.8 times 10 to the 24. Now, that's pretty straightforward. They like to say things like sodium chloride. How many moles of sodium ions are there in a mole of sodium chloride? Well, there's 1 mole of sodium ions in a mole of sodium chloride. Magnesium chloride, how many moles of chlorine ions are there in a mole of magnesium chloride? Well, there's 2 moles of chloride ions in a mole of magnesium chloride. And that's, it's quite straightforward when you understand that. Question 7 is all about corrosion. It says many metals corrode. When a metal corrodes, the answer is D. The metal is oxidized. It gains oxygen, and most of us were okay with that. Part B says an experiment was carried out to see if magnesium ribbon wrapped around a piece of iron rod had an effect on the rate at which the iron rod rusts. And you've got 2 test tubes, both exactly the same, with some water, both with iron rods, one with magnesium wrapped around in it. And it tells you a method here. Both boiling tubes are left for a few days. Explain why iron rod rather than stainless steel rod is used in this experiment. And that's a 2-mark question, and it says explain. Now, you need to say that stainless steel doesn't rust, but iron does. But you only get 1 mark for saying that. It's not 1 mark for stainless steel doesn't rust, but iron does. That's not the 2 marks. The 2 marks were for saying stainless steel doesn't rust, and therefore you wouldn't see an effect between the 2 test tubes. So it says neither rod would rust or no change would occur in either test tube. So stainless steel does not rust, so you would not see an effect from the magnesium, or you would not see an effect in either test tube. Something along those lines in order to get yourself the 2 marks. Part 2 says state why it is not necessary to use a pipette to measure out 10 centimetres cubed in this experiment. Well, they're not talking about a disposable plastic pipette, they're talking about a glass pipette which you use for titration, which is highly accurate. It's a glass pipette is a highly accurate way of measuring out a volume of liquid, and you use them in titrations. Now, it's not necessary to use a pipette because the volume of water that you need doesn't have to be measured out accurately. So the accuracy is not needed. The accuracy of pipette not needed. It doesn't need to be that accurate. It then says after a few days the 2 boiling tubes were examined. The results are shown in figure 5. Explain the results in this experiment, and that's a 2 mark. And so the explain is relating it to the science of sacrificial protection, but you don't get the mark for saying sacrificial protection. You get the mark for saying that magnesium is more reactive than iron. And so what happens is you see that magnesium has corroded in preference to iron because magnesium is more reactive than iron. So magnesium has corroded in test tube A in preference to iron because magnesium is more reactive than iron. Now, you would have got the 2nd mark just for saying magnesium has corroded instead of the iron. And you could have, if you said that magnesium has corroded instead of the iron, you would get 2 marks. But it's much better if it's explained to make sure that you say it's corroded because it's more reactive than iron. That gets you that 2 marks. The next one, it says hydrazine reacts with oxygen. A metal in water corrodes faster than an identical piece of metal in the same volume of water containing dissolved hydrogen. Use the information to explain how hydrogen slows corrosion. I was surprised that more of you didn't get this. But hydrazine reacts with oxygen, so it removes the oxygen from the water, and you need oxygen for corrosion. Therefore, the metal won't corrode. So the 2 marks were for saying the hydrazine reduces the amount of oxygen as oxygen is needed for corrosion. The corrosion is less. And you needed to say that the amount of oxygen reduces, and you needed oxygen for corrosion for the 2 marks. Part D, it says ammonia is used to make hydrazine. In the industrial process to manufacture ammonia, nitrogen and hydrogen are combined in the presence of an ion catalyst. And then it gives the equation for the Haber process. State the name of the industrial process. It's the Haber process. Most of us were happy with that. Predict the effect of adding a catalyst on the rate of attainment of equilibrium. Well, it increases. Catalysts increase the forward and the reverse reaction, and therefore equilibrium is attained more quickly. Predict the effect that adding a catalyst had on the equilibrium yield. Well, it has no effect because a catalyst doesn't alter the position of the equilibrium, it just alters the speed that equilibrium is obtained. And most of us were happy with that. Question 8 says pieces of zinc react with copper sulfate solution. Zinc sulfate solution is colourless, and it tells you that in the question. Describe what you would see when an excess of zinc is added to copper sulfate solution and the mixture left until the reaction is complete. Well, you really have to understand what these things look like. This says zinc solid. Zinc is a silver metal. Copper sulfate is a blue solution. Zinc sulfate is a colourless solution, and copper metal is an orange solid. So what you would see is the silver solid would start to disappear, an orange solid would be made, and the solution would turn from blue to colourless. Now, you got 1 mark if you said it went colourless, but many of you said and copper was produced. Well, if you are what you see, you have to describe what you see. You have to say not and copper is formed and an orange solid is formed. So the best answer would be the silver metal disappears, and an orange stroke brown solid is made, and the solution turns from blue to colourless. And it's colourless and not clear because you can still have a clear blue solution. The next part says this reaction is described as redox reaction. Explain in terms of electrons which particles have been oxidized and which particles have been reduced in this reaction. Well, if you write out an ionic equation, I'm going to do it up here. You basically get rid of the sulfate ions and you get zinc plus Cu2 plus go to give Zn2 plus Cu. So zinc goes to give zinc 2 plus. Now that's going to lose electrons, isn't it? Plus 2 electrons. So zinc has lost electrons and is oxidized, so that's oxidation. Loss of electrons, and copper 2 plus goes to Cu, goes to copper, and that's plus 2 electrons, plus 2 E minus. So copper 2 plus 2 electrons, so that is reduction, and that is gain of electrons. electrons. Now, most of you were able to say that, although you didn't give the half equations. And you don't have to give the half equations, but I find it useful to put them in. Part C caused a few problems. It gives a concentration. The copper sulfate is used has a concentration of 15.95 grams per decimetre cubed. Now you've got and it says calculate the number of moles of copper sulfate in 50 centimetres cubed of this solution. You've got the equation moles equals concentration times volume, but that's when the concentration is in moles per decimetre cubed. So that doesn't really work because you've got the concentration in grams per decimetre cubed. If the concentration is 15.95 grams per decimetre cubed and I've got 50 centimetres cubed, well, that's 15.95 grams per 1,000 centimetres cubed, and I've got 50 centimetres cubed of it. So that's going to give me 0.01595 grams per centimetres cubed, and I've got 50 centimetres cubed, so it's going to be 0.01595 times 50, which equals 0.7975 grams. So in other words, my solution contains that many grams of copper sulfate. I then need to calculate the relative formula mass of copper sulfate, which CuSO4 is equal to 63.5 plus 32 plus 4 plus 16, which gives me a total of 159.5, and you've got a mark for calculate that. And then I need to calculate the number of moles in that, so it's moles equals grams over rams. So 0.7975 divided by 159.5 equals 0.005 moles, which was the answer. The second part, in another experiment, 0.043 moles of copper sulfate is used. Calculate to 1 decimal place the minimum mass of zinc that must be added to react with all of the copper sulfate. This is really quite straightforward. If I've got 0.043 moles of copper sulfate, if I look back at the equation, then 1 mole of zinc is going to react to give 1 mole of is going to react with 1 mole of copper sulfate. So I'm going to have 0.043 moles of zinc. If zinc has got a relative atomic mass of 65, it's going to be 0.043 times 65. That comes from moles equals grams over rams, so it's going to be moles times rams, the number of moles times the rams equals the grams, which is 2.8 grams. But it says to 1 decimal place, so it's got to be it's actually that figure, sorry, is 2.795, which if you round that up it becomes 2.8. Now you've got 1 mark for 2.795 and 1 mark for rounding it up to 2.8. Question 9 is all about acids, and it says X and Y are solutions of 2 different acids. The concentration of acid in each solution in moles per decimetre cubed is the same. Solution X has a pH of 3.4. and solution Y has a pH of 4.4. State what could be used to measure pH values. The best answer is a pH meter or a pH probe, but you are allowed universal indicator paper, but obviously universal indicator is not as accurate as a pH meter or a pH probe. What is the concentration of hydrogen ions in solution X compared to that of solution Y? Well, solution X has a pH of 1 lower than pH Y, so the concentration of hydrogen ions is going to be 10 times greater, because it's a factor of 10. Each pH unit is a factor of 10, but if the pH is less, then the hydrogen ion concentration is more. So the answer is going to be 10 times higher. Part B, it says an experiment is planned to record the pH, the change in pH as a powdered base is added to 50 centimetres cubed of hydrochloric acid. Now this is the same as a core practical that you did, called core practical on neutralisation. The method that is suggested: add dilute hydrochloric acid up to the 50 centimetres cubed mark on a beaker, add 1 spatula of base and stir, measure the pH of the mixture, repeat steps 2 to 3 until the pH stops changing. State how you could change the method so that the amounts of acid and base can be measured accurately. So the acid, use a measuring cylinder instead of a beaker, use a measuring and the base, instead of just using spatulas for, you could weigh out portions using a balance, and those two things got you the 2 marks. During the experiment, the pH changes from 2 to 10. If phenolphthalein indicator is added at the beginning of the experiment, a colour change occurs as the base is added. State the colour change that occurs. Well, phenolphthalein is colourless in acid and pink in alkali, so it's going to go from colourless to pink, not clear to pink. And explain in terms of the particles present, why the pH increases during the experiment. Now, the theory behind this is that acids contain H plus ions, alkalis contain OH minus ions. You're going from an acid to an alkali, so the hydrogen ion concentration decreases and the hydroxide ion concentration increases. But you only got 1 mark for saying either one of those. And the reason is because the acid is neutralised. And the neutralisation reaction is that the hydrogen ions react with the hydroxide ions. So you had to say hydrogen H plus ion concentration decreases because they are neutralised by OH minus ions, and then the concentration of OH minus ions increases. So, you know, of those 3 things, you had to say 2 of them in order to get the mark, but not the first one and the last one. Now, part C, it says some properties of 4 solids, A, B, C and D, are shown in Figure 6. The solids, in no particular order, are copper carbonate, copper oxide, magnesium metal and sodium hydroxide. Now, the question is part of a question all about acids. And in order to answer this question, you've got to understand that there is some information about whether those things dissolve, but and then it tells you what the pH of those things are, And then it says observation 1 solid is added to acid. And this row here is really the most important row in answering the questions, because you could answer the question just by getting that row correct. Now, you've got four things, and they are copper carbonate, CuCO3. You've got copper oxide, CuO. You've got magnesium metal, and you've got sodium hydroxide, NaOH. Now, that is a carbonate, a metal carbonate, a metal oxide, which is a base, a metal, and you've got sodium hydroxide, which is a base, but it's also soluble. Copper oxide is insoluble. I know that, and you should know it because you've done a core practical using copper oxide as an insoluble base to neutralise an acid. But sodium hydroxide is a base and it's soluble, so it's also an alkali, because an alkali is a soluble base. So in this row where I'm adding these four things to acid, I would expect to get, if it was a carbonate, I would get Cash-O-Co. I would get salt plus carbon dioxide. If it was a base, I would get Basho salt plus water. So I would get this, I would get CO2. This would just be H2O. Metal, I would get salt plus hydrogen. And this, I would just get base plus water again. So two of those things I would expect to fizz. One giving off carbon dioxide and one giving off hydrogen. Two of them I wouldn't expect to fizz because they just give off water. Now, I've got effervescence, which is fizzing, in B, and I've got effervescence, which is fizzing in D. The fact that B is a silver solid and it effervesces immediately tells me that magnesium metal must be B. The fact that the green solid, I know copper carbonate is green, but the fact that that's the only other one that fizzes and it's green, copper is a transition metal. Transition metal compounds are coloured, and therefore the fact that copper carbonate is green is D. Copper oxide, you should know that copper oxide is black because it's the black powder that we added to sulfuric acid to make copper sulfate. And you've done that as a core practical. That would tie in to the fact that it forms a blue solution, although this forms a blue solution as well, but adding a black solid to a blue solution, that was copper oxide, and you should know that. So A is copper oxide, and that leaves sodium hydroxide to be C. Now, I can confirm that because my carbonates don't dissolve. So the fact that the green solid remains with copper carbonate is good. Sodium is a group 1 metal, so sodium hydroxide will dissolve. It gives an alkali, we know that. So, sodium hydroxide is a white solid, but you normally get it in solution as an alkali. So the fact that it dissolves to form a colourless solution would imply that. The fact that magnesium in water, magnesium does react with water, but very, very slowly. And you should know that when we did about group 1 metals reacting with water, we said group 2 metals react a little bit with water, calcium reacts with water, and copper oxide doesn't react with water. The giveaways with the pH is that sodium hydroxide is the only one that's going to give a very high pH, so it's the only one that's an alkali because it gives a high pH. Magnesium, yeah, gives slightly alkali, but that's how you would answer it. And the 6 marks were for assigning all 4 of them and also saying about the reactions. Question 10 says nitric acid can be titrated with a solution of ammonia. State the type of reaction that occurs when nitric acid reacts with ammonia. Well, ammonia is a base, and so it's a neutralization. And you got 1 mark for that. What salt is formed in the reaction? Well, you're going to get an ammonium salt. Acid plus ammonia makes ammonium salt. And because it's nitric acid, it's going to be ammonium nitrate. And part B, it says in one stage of the production of nitric acid, nitrogen oxide, NO, is reacted with oxygen to make nitrogen dioxide. Calculate the minimum volume of air measured at room temperature and pressure required to react with 300 grams of nitrogen oxide to form nitrogen dioxide. Assume that air contains 20% oxygen by volume. So we're going to have to work out the amount of oxygen and then multiply it by 5 to give us the amount of air. So if you look what you're given in the question, you've said that you've got 1,000 grams of nitrogen oxide. So I've got 1,000 grams of this. I want to work out how much oxygen reacts with it. So the first thing I can do is work out the number of moles of something. Moles equals grams over RFM. So that's 1,000 divided by the RFM of nitrogen monoxide, NO, which is 14 plus 16, which is 30. So 1,000 divided by 30, which is 33.3 moles. Now I want to find the number of moles of O2, which 2 moles of NO react with 1 mole of O2. So the moles of O2 equals 33.3 divided by 2, which equals 16.66. Now the question says that what I want to find out is calculate the volume of air. So I want a volume of oxygen. At the moment I've got a moles of oxygen. If I want to turn from moles into volume, I need moles equals volume in decimeters cubed divided by 24. Well, this is moles, so if I multiply that by 24, 16.66 times 24 equals 400 decimeters cubed. So the volume of oxygen that I want is 400 decimeters cubed. So it's the volume of air is going to be 400 times 5 times 5, which equals 2,000 decimeters cubed. And that was the answer, 2,000. Now, the last 6-mark question says, in another stage of the production of nitric acid, ammonia is reacted with oxygen to form nitrogen oxide and water. And then it gives an equation, and it's a reversible reaction. Heat energy is given out when ammonia reacts with oxygen oxygen. So this is plus heat is how I would do that. It's an exothermic in the forward direction, it gives out heat there. The conditions chosen for the reaction are excess air rather than just the right amount of air, a pressure of 10 atmosphere rather than atmospheric pressure, so it's done at reasonably high pressure, and a temperature of 900 degrees C rather than room temperature, so it's done at a reasonably high temperature. Explain the effect of the conditions chosen on the equilibrium yield of nitrogen oxide and the rate of attainment of equilibrium. So the way that I'm going to answer this is that I've got three things. I've got concentration of excess air, concentration of O2 essentially, isn't it? I've got the pressure, and I've got the temperature, and those things are going to affect both the yield, and which one should we do first? It says equilibrium yield and the attainment of equilibrium. So this is the yield and the rate of the reaction. So I've got three things. I've got three things that I could change and two things that they could affect. How quickly the equilibrium is established, that's the rate of the reaction, the rate of the forward reaction, the rate of reverse reaction, the rate at which the equilibrium is attained. And I've also got the yield, which is the position of the equilibrium in terms of where the equilibrium lies, and Le Chatelier's principle. Now, let's deal with each one at a time. And actually, I'm going to do rate of reaction first of all, because most people have been taught rates of reaction in topic 7, and we're probably happier with rates of reaction than we are with equilibrium yield. So the effect of concentration on rate is that if I've got more oxygen, the rate of reaction is going to be faster, so it reaches equilibrium quicker. So increase in concentration means a faster rate of reaction. Increase in pressure means a faster rate of reaction, and increase in temperature means a faster rate of reaction. So if I increase all of those three things, I'm going to increase the rate of the forward reaction. And the reasons for that is that more particles, more frequent collisions. This is more frequent collisions because the particles closer together. And the temperature is I get more energetic collisions and I get more frequent collisions. So more frequent, more energetic collisions. So I get that double whammy, that double effect that you get with temperature. So I get more frequent, more energetic collisions, and that's because particles move faster, and therefore they collide more often and with more energy. So that was 3 marks if I said those 3 things correctly. And all of those conditions mean that equilibrium is established quicker. Now, the yield is Le Chatelier's principle and how those things affect the position of the equilibrium. Now, if I increase the concentration of one of my reactants, the equilibrium is going to shift to the right hand side to try and decrease the increase in concentration. So I'm going to put the yield, and that increases yield, so it increases to decrease concentration. The pressure, if you work out the number of particles I've got on each side, I've got 9 particles on this side, 5 and 4, and I've got 4 and 6. I've got 10 particles on this side. Now, if you increase the pressure, which is what it's saying, it's going to 10 atmospheres rather than 1 atmosphere, it's going to shift it to the side with less particles, which is the side of the reactants rather than the products. So it's going to actually decrease the yield of the product, and that is because it shifts to side with less particles. And if the forward reaction gives out heat, if you heat it up to 900 degrees C rather than room temperature,